Recording is rolling. It is Tuesday, September 23rd. We're getting going too far. I got a couple of envelopes in my teacher mailbox. So this is related to National Youth Leadership Forum. There's one for engineering and there's one for medicine and healthcare. So these are actually two separate events. I think there's some other ones too. Just looked up from my mailbox. This is like a summer camp program for engineering and medicine and healthcare. So if you're interested in this, then see, it could fill us out with your name and your mailing address and so on. You can talk about this with your parents again if you want to do like a summer camp type program. I think it costs a few $1,000. So, but if you were interested, you thought your parents might send you, then I will put up these two tables. Right? So it has all the same information, so name, mailing address, and so on. Right? So one's for engineering, one's for medicine and healthcare. I will set these right up here, and if you're interested in that, then those will be out to this class period, and then I can write that in later. All right, so yesterday, you guys were working on these labs, so I'm going to give you guys a recap, bring you guys back into physics mindset. Right, so you have one lab page related to friction, right? And each of these labs has two halves to it. Right, so one of these, you are pulling the block horizontally across a surface at constant velocity. Guys, why is constant velocity important? What do you know? Yeah.
Is that the net force from zero?
The net force is zero. Yeah. And if the net force is zero, you might have a lot of individual forces. In this case, I'm looking at 4 on this free body diagram. Okay? But they all zero out, which means that the pulling force equals the friction force and the weight equals the normal force. Now, the question you're trying to address, right, what's sort of the main goal, is to figure out what's the coefficient of friction between two particular surfaces. Isn't that this Greek letter mu? Right? It's the coefficient of friction. The coefficient of kinetic friction, since it's sliding, isn't it? Yeah. Now, there is a completely different way to also get coefficient of friction, and it's not using the spring scale. It's using, as a measuring tool, a protractor. So what you do instead, and some of you guys got to this part yesterday, is you can put an object on an incline and then raise the incline until it naturally slides down at constant velocity. And then you can use your protractor to measure what is that angle. That by itself would be enough information to determine the coefficient of friction. Okay, now here's the full proof for how that would actually work out. Now, I'm really giving you guys maybe too much information because I wanted to see if you guys could figure this out empirically and then put this on the lab table. Right, so you can see what angle does it naturally slide down constant velocity for different lab weights. Ooh, you can change out lab weights. You guys have a whole box of lab weights. Okay, a box of lab weights going on. Okay. Now, I did hand you guys out the write-up for each of these. So on the left side is finding coefficient of friction using only a spring scale as your measuring tool. Look at that. Okay. And on the right side is the same question, but you can have this completely different setup. And the only measuring tool you really need is a protractor. Okay. And you might say, well, what about the lab masses? But the numbers are stamped for lab masses, so that's sort of like a given value. So you don't actually need a measuring tool if it's sort of given. Right. Now, the other side of this paper is completely different labs. We're looking at Atwoods going on here. And so let's break out some Atwoods. Right. So on the left side is this classic Atwood, or sometimes I call this a double elevator. Right. You got two different weights. Okay. The question you're trying to address is what is the acceleration of the system as a function of these input masses, M1 and M2. And so maybe I have, maybe these could be my two masses. I have 100 grams versus 200 grams, for example. Okay. The big one's always going to accelerate down. The small one's always going to accelerate up. But at what values? Now you can determine this kinematically with the meter stick and the stopwatch. Okay. And then can you connect that back to like any general mass? So what if I call this 5 kilograms and this 6 kilograms? Could you predict what the acceleration would be? I'm covering up the proof over here. Okay. And then on the right side of the slide page is this modified Atwood, which looks more like this right here. Okay. So what if you have one of your masses is actually acting as a weight that pulls down with an external force? That's this weight right here. Okay. And the other one, okay, sure, it has a weight, but that weight is canceled out by the what kind of force is this called? Normal force. Okay. So, because if you make this more and more and more massive, does it overall slow down the system?
Yeah.
Yes, but not because of a force, but because of like inertia or mass. Like the more mass, the more inertia. Right? At least I'm thinking more in the dynamics context. But again, you guys can see how far does this move and how much time starting from rest. You can automatically determine what is the acceleration. And it's the same target question: is what is the acceleration as a function of the input masses in 1 and 2. Now, I do want you guys, since you guys are AP, to do one AP style write-up. So that's 4 type experiments, right? There's 2 ways to determine coefficient of friction, and then you have the classic Atwood and the modified Atwood. So it's like 4 experiments that we're doing over these 3 days. Okay. So just take one of those 4 and do an AP style write-up. Okay, so question, measure equipment, procedure, and 4 or 5 steps, usually 6 steps. Analysis, in this case, well, these graphs on the friction lab or maybe equations you can determine from the Atwoods. Okay. And then conclusion to answer your question. Okay. I did tell you guys yesterday also, of course, I did do the 2 friction ones for you. So if you wanted to, you could just basically follow one of these, either the left side or the right side. Question, measure tools, data gathering procedure, analysis, and conclusion. Okay. If you want to challenge yourself a bit, you can do the Atwoods. That would be okay too. That one I did not type up and give to you. So good. Figure it out. All right, so there you go. All right, so this looks like a pretty good pacing because my earlier class finished most of this by the end of the day, but they still have a little bit to go. And so I think have some time to do this on Wednesday. All right, so I'll close down this recording and walk around and help you guys out.